question. Just imagine the particle, angular momentum of a particular particle. See that it is one of the year, I think, even it's like 1997, they asked the question related to this. You can see that, of course, every year there is a question, we'll solve it. So imagine there is a horizon, okay, and particle of mass m, and having a velocity v. That's all. So now the question, you write it first. A particle of mass m is moving with constant velocity. With what velocity, everybody? Constant velocity v parallel to x-axis. Parallel to x-axis. Its angular momentum about the horizon is. Its angular momentum about the horizon is. That is what is the question. Its angular momentum about horizon is. So option A, 0. Option B, constant. Option C, goes on increasing. Option D, goes on decreasing. So that is the question. Okay, so it's very important and very interesting also. So let us make attention, everybody. So please remember, if you not understand, you can ask me, because basic, this is by the time it is very tough, but now you will feel easy, but it still is okay. What is your expected answer? Let's try, everybody. Take 2 minutes time and you try. So what is your answer? So first understand the question. What is the question they are asking? See that a particle of mass m is moving with a constant velocity v, which is parallel to what? Parallel to x-axis. That is what. So this is what is our x-axis. Am I right or wrong, everyone? Yes, please. All of you respond. That is what. Now imagine before the particle is here, it is moving with a constant velocity. So constant velocity means after certain time, the velocity of the body will come to this point. Am I right or wrong, guys? For those, understand now? Yes? Now initially the point is at here. Let me imagine now, which is at r distance, and having a theta is having an angle theta. What is the theta? Theta angle. Clear, everyone? So now you tell me, if you move from, yeah. So what is that now? What is the perpendicular distance here? R cos. What is the perpendicular distance? If here is the theta, means here also theta. So what is this, everybody? Let me take this distance is r. So it will become what? R sin theta. Okay? R sin theta. So can you tell me what is the momentum at this point? Angular momentum. L is equals to. Angular momentum L is equals to. What is the formula? M into V into R sin theta. R sin theta, which is equals to what? M into V into R perpendicular. Any problem for anybody? R perpendicular. Understand, Rudrasa? Now, after certain time, it is moving parallel to x-axis. Parallel to x-axis means in the same direction. Parallel to x-axis. Still velocity remains what? Everybody. Velocity remains what? Please respond. Constant. Velocity remains constant. Now imagine body came to this point. Now you tell me. I'll draw with another thing. Now, do you think that the theta is remains same? Do you think that theta is remains same? All of you. My question is to you guys. R is remains same. Now distance R is remains constant. Let me take this is R dash. Now you tell me, is it theta is remains constant? Where is R? That is what is my question. Yeah, from here to here, theta will changes or not? Now I will draw like this. This is the theta. Now the theta came here. Now is it both thetas are same? No, sir. No, that is what I am saying. So that, or let me take this is a theta dash. Now if it is theta dash means now it is here the particle is moves. Now here you can notice it. What is the R perpendicular? Can you tell me what is R perpendicular now, everybody? What is that? You should speak. R dash. Are you clear? R dash sin theta. Understanding? So let me take now again for this particle, right? At this point you write it. MV R dash sine theta dash, which is equals to m into v into, this will become what? R dash perpendicular. Am I right or wrong? Everybody? Yes? Please respond.
Yes, sir.
That is what. Now, if you observe this r sine theta is r perpendicular, r dash sine theta is, I have taken r dash perpendicular. If you observe very carefully this picture, if it is moving with a constant velocity, let us comes to next point. Let me take at this point. Here also velocity remains what? Everybody. Velocity remains what? Constant. Am I right or wrong? So let me take that is the r double dash. And what is the perpendicular distance? Anybody can tell me?
R double dash sine theta.
R perpendicular distance is r double dash sine theta double dash. Let me take this theta double dash. Clear? But if you notice it, everything, is it all are equal or not? Height. R perpendicular is remains constant or not? Everyone. Yes or no? Let take R perpendicular is D here. Then what about here, brothers? R dash perpendicular also what? D only. And here also R double dash perpendicular also what? Everybody.
D.
Understanding? So everywhere I can write at any point, you can say MVR double dash sine double dash, which is equals to MVR double dash perpendicular. So everywhere the height of the particle, that is what? The perpendicular distance remains constant. I will get MVD. And here also what I will get? MVD only. Here also I will get what? MVD only. So everywhere the momentum, angular momentum remains what? Everybody. Remains constant. Understanding? So that is what. See how simple it is. The concept, if you understand, it is very, very basic sum. So it is one JEE, they ask this sum. Do you think that? So any doubt in this question you ask me. Mr. Narayan, understand? Rohit? Kadri? Clear? Rudreshwa?
Yes, sir.
Theta varies. Theta varies. I'm not saying about the theta, it remains constant. But angular momentum remains constant or not? Everybody. Theta may varies, but the perpendicular distance, because it is parallel to x-axis, so the perpendicular distance remains same. So you can find the direction. That is very important. Now here, apply right hand thumb rule and tell me R to V. R to V. What is the direction of angular momentum? Everybody. Angular momentum direction, R to V. Apply the right hand thumb rule and tell me. R to V. Perpendicular only. It is acting inwards or outwards? Into the plane. Understanding? Into the plane. Here R dash to V. Apply right hand thumb rule. Same direction. Clockwise or anti-clockwise? Here also clockwise only. So into the plane. Here R double dash to V. Apply right hand thumb rule. Still what is that? Clockwise only. So everywhere, what is the direction of angular momentum? Remains? Everyone? Remains same. Understanding? So that is what angular momentum remains constant if a particle is moving with a velocity which is parallel to x-axis. That's all it is. Very simple. So it is not theta goes on decreasing, you can see. If the particle goes some other way, then theta will goes like this. Theta varies, but angular momentum remains constant. And mass of the particle, same mass and same velocity. Velocity is constant and mass is also constant. So that there is no change in the angular momentum of a particle in a system. That is what I want to say. Are you clear, everybody? Understanding? Yes, please. All of you?
Yes, sir.
Yeah. So this is what it is. So when you are solving, of course, remember, I have seen almost 10 to 15 years of last NEET and JEE papers. 95% of cases, there will be a question related to angular momentum, either system of particle, like three actually, we are having a rigid body, rotating rigid body, or we are having a what? A particle point of mass, or rotating rigid body, or rolling body. In these three, any one angular momentum related, 100% there will be a question. Even last year NEET paper also you can check it. Last year JEE paper also you can check it. JEE up to JEE mains 100% they will ask you the question from this. That is the importance of it. So please practice. Then tomorrow's class we will study angular momentum, rigid body, and as well as rolling body. Okay. Now you do one thing. 1 minute.